What's up guys, it's Iman Fiaz and today's video is on 8th grade level chemistry atomic structure question paper. The goal is to finish these question papers with you guys before 1st of May. So then the rest of the time until like 15th of May or like after my psychology exam, I'll just be going through practicals with you guys, mechanisms, practicals, just flashcards, just no past paper questions. And then during the half term, again, go to past paper question. I did want to actually go through the old spec questions, but I just don't have time. And if you have to choose between new spec questions and old spec questions, obviously choose the new spec ones, and that's what I'm obviously doing. But again, I don't. A lot of people are saying to me it's not worth it going through old spec questions. So yeah. So state two features of current model that are not shown in the Rutherford model. Feature one of the current model is that it includes neutrons and protons. Includes neutrons and protons. And current model shows the electrons in different energy levels. The second one is probably where most students would not get it. That second mark for the second feature shows the electrons in different energy levels or different orbitals. So one feature of current model includes neutrons, protons. Another feature shows electrons different energy levels / orbitals. Give the symbol include the mass number of the ion that reaches the detector first. Well, if I read the question, it tells me it's a sample of tin. The one that's going to reach the detector first is the one with the lowest MZ value, so 112. So therefore, it's just going to be the symbol of the ion 112 tin, which is SN. But here's the part most students will get wrong. It's ionized by electron impact ionization. And remember, electron impact sample is dissolved, and electron gun is used to fire high energy electrons, knocking one electron off each particle, therefore becoming 1+ ions. So it's going to have a positive charge. Whereas electron spray sample is dissolved and pushed through a nozzle at high pressure, high voltage applied to it, causing each particle to gain H+ ion. But yeah, and then calculate relative atomic mass. That's going to be very easy because all I have to do is find out this, which is 100 minus 22.41 plus 11.78 plus 34 minus 97, because obviously percent, so percentages add up to 100 generally. So then once I've got that, then the relative atomic mass is just going to be that times by that plus this times by this plus this times by this plus this times by this, which is that, divided by 100. I'm not going to go through all of that. Very simple question, and you should get 116.5. Now, does it tell you on the front of the paper? It does tell you in the question, but I'm just looking for in general. This is not even a past paper, this is a question paper, man. In a time of light mass spectrometer, molecule X is ionized using electron spin ionization. What is the equation for this ionization? Now I can already eliminate A and B, 2 electrons, that was immediate giveaway, but then also why would I add electrons? So I'm left with C and D, and in this case it's going to be D. Like it's a very nice question because of the idea that, remember, with first ionization energy, with electron ionization, all of this, they have to be in a gaseous state. The definition of all of these requires the gaseous state. What's the electron configuration of V2 plus in the ground state? Now I do have my periodic table. I will get one right now because if there's one question paper I want to get out of the way, it's this one. Because in my opinion, this one sucks the most because it's probably got the most questions. And no, atomic structure is the first topic you learn, so it's the one you're most likely to forget everything as well. So I definitely want to go through all these questions as well. So V2 plus, well, one second, guys. Let's get my phone somewhere. Okay, V2 plus. Well, if I look here, V, I see it's got 23 electrons. Obviously, the electron, let's say that's A, that's Z, and that's X. That is the mass number. Mass number. That is the atomic number. Atomic number. Atomic number of protons in the nucleus identifies the element, and mass number, total number of protons and neutrons in the nucleus. Just a quick review. But yeah, what I'm looking for is that. So 23 electrons, right? But because it's got a V2 plus, I'm going to subtract 2 electrons. Subtract 2, therefore I'm going to have 20. If I'm going to have 21 negatively charged electrons. So which one could it be? Well, if I add these all up, when it's to 4, 10, 12, 18, 21. 4, 10, 12, 18, 19, 21. 4, 10. No. I think what a better thing is for me to just draw out V originally. So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4, 10, 12, 18, 3p6, 4s2, 4, 10, 12, 18, 20. I need 3d3. That's for 23 electrons. But remember, V is vanadium, which is a transition metal. Is a transition metal. So because it's a transition metal, first things first, it's going to be 3d3 for us too, and it's also going to lose the it's going to lose the 4s electrons before it loses the 3d electrons. So therefore, it's going to be A. A lot of work for just one multiple choice question. But yeah, question 4: which atom has one more proton, two? But I'm really like trying to explain every detail for it. So yeah, you guys hopefully understand it. Which atom has one more proton, two more neutrons than this? Well, P, phosphorus, 31 minus 15, 31 minus 15 equals 16. So that tells me it's got 16 neutrons. So which one has two more neutrons and one more proton? Well, again, that is the mass number and that is the A number, atomic number. So if it's got one more proton, this atomic number of protons in the nucleus is going to increase by 1, so it's going to have 16 here. But this also, the number of neutrons increases by 2, so I'm going to have 18. Now, therefore, 16 plus 18 will give me 34. So there we go. 34, 16. So therefore, it can't be A, it can't be C, and now I'm left with a predicament. Is it B or D? Well, they both have the same structure, 34, 16, but one is phosphorus, one is sulfur. Well, remember the definition of isotope. Isotopes are atoms of the same element with the same number of protons, but different number of neutrons. This does not have the same number of protons, therefore it's not an isotope. And because we've altered the number of protons, we've changed the whole element, so therefore the answer is D. Too many multiple choice questions, man. I want to go through some actual questions. The first 7 successive ionization energies for element Z are shown. What is the element Z? So we look for where the big jump in ionization energy, which is clearly here. And yeah, so it's got to be in group 4. So that tells me it's in group 4 because electrons being moved from the 4th outer shell. So therefore, if I use that, well, it can't be phosphorus because that's in group 5. It can't be nitrogen because that's also in group 5. So I'm left with carbon and silicon. But Iman, how would I differentiate between these? Good question. If you look at the bottom of the scale, ionization number, that tells you the number of electrons. So that's when one electron is being moved. That's when two. That's when three. That's when the fourth electron is being moved from outer shell. That's when the fifth one is being moved from outer shell. And you can see each time being moved from increasingly positive ion. But I can see it goes up to 7. How many electrons does carbon have? It's got 6. So it, and I can see here at 7, there's still electron there. So it can't be carbon. It's got to be silicon. That's a nice little trick they like to use to find the mass number of an atom. Just good number of protons. I went through this just before. Number of protons. Number of protons plus neutrons. You could say in the nucleus, but not necessary. Part B, complete table below to show the numbers of neutrons and electrons in species shown. So with titanium, if I look here, Ti, I can see I've got a 22 on the bottom. So the number of neutrons is going to be 46 minus 22. I'll do 46 minus 22 for 24. So that's going to be 24. The number of electrons is just going to be 22. In this case, I've got 2 plus charge. Well, again, it's still 22. So the number of neutrons is 27. The number of electrons, though, is going to be 22. Or is it? Well, because of that 2 plus charge, then I'm going to minus 2 then. Therefore, I get 20. And this is from a real A-level. Obviously, all of these are A-level chemistry paper, class paper questions, but this one's like from actual A-level paper, not AS level. So that's interesting. They that's 2 marks for that. It's testing your skills from atomic structure. Part C, a sample of titanium contains 4 isotopes. Sample has relative atomic mass 47.8. In the sample, the ratio of abundance is this. Calculate percentage of abundance 46 Ti in the sample. Very difficult question if you've not been exposed to this kind of material, this kind of question before. If all you've been exposed to, like me, is like this kind of question, calculate relative atomic mass, it gives you basically everything. You just need to 100 minus up. So yeah, it gives you everything. It's going to be very difficult. Well, I know the relative atomic mass is 47.8. That's the first thing. And I'm going to create well, I need to create 4 brackets, one for 46, 147, 148, 149. So that's another bracket. Okay, let's make this a bit shorter then. 47.8 equals something times by something plus something times by something plus something times by something plus something times by something divided by something. Now I know all of these. I know the ratio of abundance is that. Well, 49 is the 1 ratio. So I'm going to let 49 Ti equal Y. So if I want to find out the percentage abundance of it, it's just going to be 49 times by Y. So 49Y. But if that's Y, then 47 Ti, well, that's going to be 47 times by 2Y. And 46, well, 46 is 46 times by 2Y. But what about 48? And this is the most difficult part. 48. What is 48? Well, 48 is... Well, obviously I'm going to write down 48 here. But it's not 2y, it's not 2y, it's not 2y. If I add those all up, I get 5y. So 48's got to counteract that. 48 has got to be, well, obviously I'm divided by 100 again because it's percentage. It's got to be 48 bracket 100 minus your 5y. 100 minus your 5y. And then you rearrange it. So you move that to the right side, collect your like terms, collect the y's, and you should get y equals 4, but that's not the answer. 46 Ti, well, I let 49 Ti equals y, but I want 46 Ti, percentage under 46 Ti, well, that's a 2. So it's 4 times by 2, which is 8%. So again, and another little trick as well. But yeah, once you've used this information, so that's let this equal y, then that's 49y, that's 47 times by 2y, that's 46y. Then 48 has got to be, well, a percentage of total 100 minus these y's because I want to counteract them. There you go. Which has the electron configuration of a noble gas. Well, if I look at H plus, hydrogen has one. Actually, let me look at selenium. Selenium Se has 34 electrons. Well, let me just go through what the noble gas is. The noble gases is it. You've got helium, neon, argon, krypton, xenon, radon, organocon, and then lutetium, lawrencium. You don't need to know those ones. So which one's going to have that? Well, H plus definitely. Now oxygen, well, oxygen's got 8 electrons plus 1, 9. Nope, none of the noble gases have that structure. Se2 minus, well, Se has 34 electrons. 2 minus, I'm going to add 2, 36 electrons. And do any of these noble gases have 36 electrons? Boom, krypton. Argon, krypton. Has 36 electrons, therefore it's selenium. That's what it's testing you. And it's quite difficult in my opinion because it's not explicitly clear what it wants you to do. Like, does it want you to compare the noble gases, or is it giving you one of these noble gases? And Zn2 plus, well, Zn's 30 electrons, 2 plus minus 2, you get 28 electrons. None of the noble gases have 20 electrons, so can't be Zn2 plus as well. Define the term relative atomic mass. The average mass of an atom of an element on a scale where an atom of carbon 12 is 12. Average mass of an atom of an element on a scale where an atom of carbon 12 is 12. Calculate relative atomic mass for this example of krypton. So now this one is a really nice one. Very, very nice. But actually there's a trick for this one. There's no mention of percentage, right? It's relative atomic mass. So I'm going to do the same thing, which I guess what I'll do in this case, because I need to show this key skill that before you guys, if you're in year 13, before you go into your summer exams, do not assume it's going to add up to 100. Because if you do that, you're going to get this wrong. Because it's not. Read the question properly. It's not mentioned a percentage at all. And if you just look at relative densities, no way that adds up to 100. It adds up to 43, and then you get 84.1. But if you divide it by 100, I don't think you would have got any marks. In a time of flight mass spectrometer, ions are accelerated to the same kinetic energy. The kinetic energy of an ion is given by the equation K equals a half mv squared. Each ion is accelerated to kinetic energy of this, and the time of flight is that. Calculate length in meters of the time of flight tube Avogadro's constant is L equals 6.022 times 10 to the power 23 moles to the power of minus 1. So, classic question, definitely going to come up on the summer exams or questions similar to this. Time of flight mass spectrometer, 5 marker. It's actually not that difficult once you've done a bunch of them and you're extremely confident with the formulas. So each ion is accelerated kinetic energy KE equals 4.83. This is what I would do if I knew exactly what to do then, but in this case I'm not fully sure. So I'm going to write down everything, label everything, like in a maths exam. If you've got a formula, you're going to label which parts of the formula you have to find out which unknown you want to find. And I know L is that. I want to calculate length of flight tube. It's only giving me that, has it? But no. It tells me it's 84 kR plus ion. So with that information, I can find out the mass of the ion. And then therefore, I can use, well, K equals a half mv squared. Rearrange that. M equals 2ke over velocity squared. And velocity, actually no, would that even work? So if I find out the mass, no. What I need to do is I need to find out the velocity then, because I can already find out the mass. So what's the unknown here? Well, it's velocity. So therefore, velocity squared equals 2ke over m. V equals the square root of 2ke over m. And I would memorize these beforehand as well, because these are worth 5 marks, 4, 5, maybe 6. You don't want to, not get those easy marks just because you couldn't be bothered to memorize some formulas. So yeah, you find out the velocity, square root of 2ke. Well, what is a mass, Simon? Sorry guys. The mass is going to be 84 times by 10 to the power minus 3, 0.08, no, yeah, 0.084 divided by Avogadro's constant, which is L 6.022 times by 10 to the power 23. Anytime they give you this in a question, alarm bells should go off. I am 100% going to use this. I've done a bunch of past paper questions for chemistry, obviously all new spec, but anytime they give you this, 9 out of 10, okay, 99% going to use it. So you find out the mass, 84 divided by 1000 divided by Avogadro's constant. Then you rearrange this formula, or you can memorize it. So V equals already square root of 2ke over m. Square root of 2ke, or square root of 2 times by the kinetic energy, over the m, which you've just got. And then you've got velocity. And then recall the formula, velocity equals distance over time. Therefore, the length, which is the distance equals velocity, which you just worked out from that, times by the time, which it must give you the time, otherwise got it completely wrong, 1.72 times by 10 to the power minus 5. And then it should give you 1.44 meters, 1.43 meters. So actually, not very challenging once you spotted that you can find a mass of that using Avogadro's constant, and this you can rearrange this to find out velocity. So yeah, memorize these formulas. Which atom has the smallest number of neutrons? Alhamdulillah. You know how to do this one. This is a multiple choice question. It's the lithium. What I would do is just write down, look at the periodic table, write down what's in the bottom of each one, and then you can find it out eventually. 10b, What is the electron configuration of atoms with only 2 unpaired electrons? So this one's slightly difficult. Well, what I would do is I would cross out everything except for these things, because I want to see with only 2 unpaired electrons. I'm going to look at these electrons, right? Obviously. So 2p3, well, how many p orbitals? There's 3, right? So if I have 1 here, and remember the rule, they prefer to occupy the orbitals themselves. I think it's called Smelly Bus rule. I'm not fully sure. So that's got 3 unpaired electrons. 2p4, well, all I'm going to do is now one of them has to pair. So if I add it here, well then what am I left with? I'm left with 2 unpaired electrons, so therefore it is B. And that's just a visual way of doing it. Maybe you guys find that useful. I find it quite useful that way as well. So yeah, literally draw it out. Remember, p orbitals are there. Give the meaning of the term relative atomic mass. Average mass of an atom. The average mass of an atom of an element on a scale where an atom of carbon 12 is 12. As long as you got this bit, and obviously this bit is really important as well, atom of carbon 12 is 12. Yeah, you get the 2 marks. The sample of chromium containing isotope 50Cr, 52Cr, and 53Cr has relative atomic mass of this. Alhamdulillah. Sample contains this much of 52Cr isotope. Calculate percentage bonds each of the 2 isotopes. Again, very similar to a previous question, if you remember, guys. But now I feel more confident with this because we've obviously gone through that one, and that other question was very difficult. I think this one's slightly easier. So it contains this much of 52Cr. So 52 times by 86.1. If you're struggling with these kind of questions, just fill in everything they give you. Fill in everything they're giving you. Well, it's percentage, so it's going to be divided by 100. I've also got 50 and 53. Now I don't know yet what I'm going to do. What am I going to do? What I'm going to have to do is I'm going to have to let one of these equal to, let's say, y, and then therefore the other one is going to be 100. Well, it's not going to be 100 minus y. It's going to be 100 minus 86.1 minus y, because I've got this, which is that much percent of that. So I'm going to let y equals 50 CR, and therefore I've got 50y plus 53 bracket, well, 800 minus 86.1, 13.9 minus x, and there you go, boom, that's it. No, 13.9 minus y, sorry, yeah. 52.1 equals 53 bracket 13.9 minus x plus 52 times by 86.1 plus 50y over 100. Rearrange. You get your answer as 50. You get x equals 1 point. Well, you get 3x equals 3.9. Therefore, x of the 53 CR plus 53 CR plus. Well, it's going to be 13.9 minus x, which is 13.9 minus 1.3, which is 12.6%. And therefore this one, 50 CR, well, I let y equals 50 CR, so that's 3y, sorry. So therefore that's just going to be 1.3%. State in terms of number of fundamental particles. One similarity and one difference between atoms of 50 Cr and 53 Cr. Very annoying question, actually. Very annoying question. But. These are clearly isotopes. Once you spotted that, just by the memorization of the definition, you can quite easily get the mark. So isotopes are atoms of the same element that have, these are the same elements, 50 chromium, 53 chromium, atoms the same number of protons, but different number of neutrons. Once you spot that, then it's easy from there. With two reasons why it's necessary to analyze isotopes before they can be analyzed in time of flat mass spectrometer. So ions can be accelerated by an electric field. Ions create a current when hitting the detector. When hitting the detector. Ions can be accelerated by electric field. Ions create a current when hitting the detector. Part E. 53 Cr plus ion travels along the flight tube of length this. Ion has a constant kinetic energy of this. Mass of the ion is this. Calculate time for this ion. Travels down the flight tube to reach the detector. Again, a 5 marker on, again, a time of flat mass spectrometry question. So calculate the time. So I've got the distance, the length 1.25. I've got the kinetic energy 1 point, it looks like 1, no it doesn't, 1.102 times by 10 to the power minus 13. I'm giving Avogadro's constant, and what did I say previously? Be giving it 100%. Obviously I ain't got proof for that. Well, actually I have, because I've done a bunch of these questions, and 9 times out of 10, okay, I'm going to say 99% chance you're going to have to use it. You use it. But just please trust me on this idea. If you see this given in a question, you're going to use it at some point in the question. So what am I going to do? Well, I need to find a time, and I know velocity equals distance over time, and therefore time equals distance over velocity. I've got the distance, I just need to find velocity. And how do I find velocity? Well, if I rearrange this equation, velocity, well, v equals, I'm just memorize this formula, I don't need to rearrange it actually, square root 2ke of m. Memorize format, ke I've got, but the mass is the thing I don't have. Well, how do I find the mass of this ion? Again, the same thing as before, 53 times by 10 to the power minus 3 divided by Avogadro's constant. And that would give you the mass. And then you just substitute it there. And then you've got the velocity. And then you substitute that into there. So it's just a bunch rearranging formulas and substituting that. Nothing complex. Especially if you do A-level maths. But if you don't, then you might find it slightly difficult. So yeah, let's check the mole scheme. Mass of the ion is velocity square root 2ke over m. Just memorize the previous that format as I recommend. They get the time as 7.90 times by 10 to the power minus 7 seconds. 7.90 times by 10 to the power minus 7 seconds. Which shows the electron configuration atom of transition metal. Transition metal, the definition, they have a partially filled D subshell. That is literally the definition. Partially filled. So it's not A, It's not D. It's not C. It's not D. It's B. There you go. Don't have to do anything. Or just use that fact from the memorization of the definition. That's empty. That's full. And that's full. And therefore that's partially filled, which it is. Question 13. Describe the molecules ionized electron spray. How do I remember this? Difference between electron spray and electron impact. Spray, like you're dissolving something when you spray, like a cleaner, like something to clean. I'm sorry, like a spray to clean whatever clothes or make the room smell nice. That's how I remember it. So electron spray sample is dissolved in a volatile solvent and injected through a nozzle at high voltage, and each particle contains a proton. Give formula of the ion that reaches detect the first time of flat mass spectrometer. Well, it's obviously going to be this one because it's got the lowest amount, but because each particle contains a proton, I'm just going to add a proton to it. And that's it. So if I didn't get part A, I wouldn't have got part B right as well. Because of the fact that I need to know that you just add a proton, a H plus ion. Give the equation clearly states in a process that occurs during the ionization of germanium atom. And because electron impact, alarm bells are going off. Electron gun used for high energy electrons, knocking one electron off each molecule, becoming a positive charge ion. So it's going to be GE gaseous arrow and GE plus gaseous plus E minus. Just memorize the format. X gaseous arrow, which I keep reviewing and it's not sticking, but yeah, memorize that format for electron impact ionization. Then whatever element they give you, germanium, just substitute that in. So that's GE, same format. It's like a formula. Calculate mass in gram of 1 mole of these germanium ions. Okay, this one definitely looks a bit more complicated compared to the rest of the time of flat mass spectrometer question we've been doing. Okay, but if I look at it, I've got the time, so I'm going to label this. Everything they give me, I'm going to label T. Okay, I'm not going to waste time and write it down. I'm just going to take it and yeah, if they've given me a lot of distance, yep, 96 centimeters converted to meters. That's a little trick, but yeah, it's not a great trick. So T, yes, they're giving us the time. They have given us the time. Kinetic energy, yes, they have given us the kinetic energy. The distance, the length of the flight tube in meters, yes, you just divide it by 100. But again, I'm giving Avogadro's constant, so there's a 99% chance. Well, I would say 100, but I guess I can't guarantee it because the question could just give you to trick you. I'm not sure, but 99% chance we need to use it. Chance, use it. So calculate mass in gram 1 mole of these ions. Well, how would I do that? Well, I can rearrange the formula. M equals 2ke over b squared. Have I got the kinetic energy? Yes. Have I got v squared? No. Wait. Oh no. Yes, I do. Because what is velocity? Velocity is distance over time. Have I got distance? Have I got time? Yes, I have. So all I'm going to do is put, this is just going to be 0.96 over the time there, squared. That's all it's going to be. And then you get the mass. So hopefully you guys get that part. then you find the mass. So yeah, find the velocity by substituting that in and square it, and you get the mass. So you get the mass of 1 mole of iron, 1.146 times by 10 to the power minus 25 kg. But it's not going to be that easy for 5 marks. Find velocity, substitute it in, or just substitute in already, and you find mass by rearranging formula. For 5 marks, no way. Well, the question says mass of 1 mole of ions. If it says mass of 1 mole of ions, I'll put this in a flashcard as well, because these questions can be very specific. If it says a mass of 1 mole of ions, I'm timesing by Avogadro's constant. And therefore I get this in kg, but it wants it in grams. And then I time by 1000, and I get 69 grams. Therefore the mass number is 69. So I'm going to actually put that on a flashcard right now. I'm just going to jot it down, not on a flashcard, but yeah. If the question states mass of 1 mole of ions, find mass times by L, where L is 6.022 times by 10 to the power 23. And then yeah, that's really it, because this part we need to spot, it says grams, so then times by 1000 again. Explain the pattern of first ionization of the elements from lithium to neon. Okay. Lithium to neon. Stage 1, your general trend from lithium to neon. First, ionization energy increases as more protons / increased nuclear charge, electrons are in the same energy level, hence no extra shielding. Stronger attraction between nucleus and outer electron. Stage 2, deviation. Beryllium and boron. Boron is lower than beryllium. Outer electron in 2p, higher in energy than 2s. Stage 3, another deviation. Nitrogen and oxygen, probably one you're more likely to remember, the idea that oxygen has a lower ionization energy than nitrogen due to the fact that the 2 electrons in what orbital, state explicitly what orbital it is, in the 2p orbital, need to pair, and pairing causes repulsion. So one piece of advice I'll give you: the general trend, you have to know what you're doing. And then this part, I would just learn a couple of examples, or the day before the exam, have a quick look at some examples of deviations, beryllium or boron. And remember, be explicit. Which orbital? The 2p orbital. The 2p orbital. Remember that. Scrap post electrospray ionization. I thought it wanted me to do something on the graph. This mass spectrum. No, it doesn't. So scrap post electrospray, dissolve, like a cleaning product, a spray to clean the room. It cleans the room by dissolving the air particles. So that will help you start you off. Sample is dissolved and injected through a nozzle at a high voltage, and each molecule gains a proton. So give the equation, well, again, each molecule gains a proton, so it's just going to be P plus H plus R pH plus. Right, there you go. What is the relative molecular mass of P though? This one's a bit tricky. Well, in this case, give me the MZ as this. This is P. Lu pentapeptide, leucine, encephalin. You don't need to know that. But the thing is that it's ionized by electron spray, and then the mass spectrum is shown in diagram. So if I want the relative molecular mass, well, because it's gained a proton, I want a minus one from this. So I'll need to do this 556 minus 1, which you can hopefully tell me is 555. But we need to be able to spot that, and that's why it's a multiple choice question. It's a one marker, but it can trick a lot of students up, including myself. Molecule Q is ionized by electron impact. Electron impact samples vaporized, and electron going used to fire hydrogen electron, like in one electron off each particle becoming H plus ion. Just so you guys know, because they ask you this question and you don't know it, you're gonna get cooked. You need to know the content, like how the process occurs of electron spray and electron impact. Calculate relative molecular mass of Q. So again, label everything. T equals 1.23 times by 10 to the power minus 5. D, the distance, the length of the flight tube, 1.50. The kinetic energy equals 2.09 by 10 to the power minus 15. Where is the formula? There it is. Obviously, by this time you should memorize K equals half mv squared, but yeah, I'm pretty sure they have to give it you. So calculate relative molecular mass Q. In order to calculate relative molecular mass, I have to first find out the mass. And again, it's giving me the Avogadro's constant, so 99% chance I'm going to use it. Is that true or not? That is true. So I'm going to rearrange the equation. So m equals 2ke over v squared, and velocity is distance over time. So I'll find out the velocity, substitute these values in, and then I'll square it, and then just substitute to here. 2ke over, and kinetic energy I've already got, so 2 this over something squared. Not too difficult. Then you get the m as 2.81 times by 10 to the power minus 25 kg. Now, if it wants a relative molecular mass of Q, you need to times by Avogadro's constant. So again, I'm going to put this key point there. If the question, because more than likely you're going to repeat one of these kind of questions, because there's only so many questions they can ask you. If the question wants relative molecular mass, do the mass times by Avogadro's constant. But in this case, then you also have to times by 1,000, because relative molecular mass is in grams, and this is in kilograms. So you do that, times by Avogadro's constant, then you times by 1,000, and then you get 169. Which atom has the greatest first ionization energy? Helium. Helium. Well, let's have a look at it. I'm going to do some explanation. Or should I? Yeah, let's do some explanation. So, hydrogen's got one electrons. Helium, 1s2, 2s2. Lithium, 1s2, 2s2, 2s1, neon 1s2, 2s2, 2p6, right? So just by first glance you might be, oh, it's here, it's this one. In reality, if you look at the noble gases, you can see you've got helium, and then neon. And you should know the general trend. The first ionization you decrease as you go down the group, but increase across the period. So with the lithium, well, lithium's here and helium's here. So if we go straight, that increases, so that's going to have it higher. But also this one's going to be lower than this one because that's lower down the group. So that's one way of looking at it, and then you can get helium. That's probably the way I'd look at it. To get helium. So two differences between Bloom-Flooded model and the model of atomic structure used today. Current model now. Central nucleus contains protons and neutrons. Current model electrons are now arranged in different energy levels / orbitals. Used for electrical configuration atom of an element R. Well, R, it tells me it's got 70 electrons, or if you didn't see that, you just count 1, 2, 3, 4, 5, 6, 7. So 1s2, 2s2, 2p3. Yeah, I don't know why I was triggering so much, because that's clearly 4, so then that's going to be 3, so that's 7. I thought it was 2p4, but that's oxygen, surely. Identify R. Well, if it's got 70 electrons, you just go to periodic tables, therefore it's nitrogen. And it says deduce the formula for the compound form when R reacts with group 2 metal in the same period as R. So in this case, you need to know the group 2 metal, beryllium, magnesium, because remember with groups that same period though as R, so periods there this way, whereas groups that way. You need to know that first thing first, and then you go to nitrogen, and then you see, okay, if I just go all the way there to left to 2 period, same period as R, is beryllium. But how is that going to help me? Well, nitrogen I'm going to check this charge the charge of nitrogen ion is -3, so Be is 2 plus, nitrogen is N3 minus, then crisscross method, you swap the charges around, you get Be3N2. Pretty difficult for 1 mark. Rather full electron configuration for each of the following species. Cl minus chlorine, it's got 17 electrons, but at this minus one's got 18 now. 18 negatively charged electrons, 1s2, 2s2, 2p6, 3s2, 3p6, 4, 10, 12, 18. Perfect. Fe2 plus, when we think about iron, is that it is a transition metal. And this will help massively with this question because you know it's a transition metal, you lose a 4s electron with 3d. So what I always like to do is just draw it out initially. So initially iron has 26 electrons, then obviously after with the 2 plus charge it's got 24, minus 26 minus 2 equals 24, but draw out the 26, 1s2, 2s2, 2p6, 3s2, 3p6, 3p6, 4s2. How many have we got left? 4, 10, 12, 18, 20. 20, 3d6, right? Or 3d6 force 2. But remember, it loses the 4s electrons before the 3d. So if it's going to lose the 2 electrons, it's just going to lose those 2 electrons. And therefore, it's just going to be that 3d6. So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. Now, if you're in year 12, looking at this, you will eventually go to transition metals, which is the final topic. I'm pretty sure is a lot of content on transition metals, but yeah. One equation representing third ionization of manganese is measured. So third ionization Mn 2 plus. Remember with this you just do the opposite. So Mn 2 plus arrow, Mn 3 plus gaseous plus U minus. Always in the gaseous state. Ions. Which one has a lower first ionization energy? Magnesium, aluminium. Now I would quickly draw out the structure, and you know what? I am going to do that. 1s2, 2s2, 2p6, 3s2, 4, 10, 12. Whereas aluminium 1s2, 2s2, 2p6, 3s2, 3p1. Perfect. So aluminium is quite clearly going to have the lower first ionization because aluminium, because it has its outer electron in a 3p orbital, which is further away from the nucleus, so easier to remove. Once you that's why being able to do this skill of drawing out the electron configuration using this is a massive skill. Because if you just made a prediction of magnesium, aluminium, magnesium, Mg2 plus, let's just say this, I could definitely see myself maybe falling for it, Al3 plus, so Mg2 plus, or the idea that first ionization energy generally increases across period. And I've got Mg here, and I've got aluminium here, so therefore Mg is going to have a high first ionization energy. So therefore Al, no, you need to, especially when it's like this, 3 marks, it's not going to be that. You need to draw out the structures to double check if that is correct or why it's not correct. Give a symbol including mass number of iron reach detector. First is nickel. It's electron impact. The electron impact samples vaporize and push through nozzle at high voltage. Each particle gains a H plus ion, so it's going to H plus ion. Nickel 58, that's the lowest NZ value, 58 Ni plus. And then calculate relative atomic mass. These are very easy now because all you do is this: 58 times by 61 plus 60 times by 29.1. Do I think you'll get this in a real exam? No. I think now they're gonna do increasingly challenging relative atomic mass questions because a lot of students struggle with it. So why wouldn't they do it? And then you should get AR, relative atomic mass, is 58.9. Chlorine exists as 2 isotopes. Which statements about peaks and mass spectrum is this correct? I'm going to skip this one because I do not know this one. Multiple choice questions can be very difficult. Which of these has the highest first ionization energy? D. Because if you look at sodium, then you look at aluminium. Aluminium is clearly going to have high first ionization energy. Then you look at silicon, then you look at chlorine. All of them in the same period. And the idea that first ionization energy generally increases across period. Or you could ask for scrap piece of paper, draw out the electric configurations of each of these, and then decide from there as well. Your choice. Again, easy. 46 times by 9.1. 47 divided by 7.8, 48. You get the point, guys, hopefully. You times these, you add it, times these, add it, you times these, you add it, you times these. Divided by 100, it is a percentage. 47.8. And I've already gone through incredibly difficult kind of questions from these in the beginning and middle of this video, so these should be pretty simple. No point of going through these ones. Run equation, electron, titanium, and of electron impact, so Ti plus gaseous, no, sorry, Ti gaseous, arrow, Ti plus gaseous. Let's see, man. They always like to ask this one for electron impact, so yeah, just seeing a couple of these. And then MZ value, well, it's one with lowest MZ value, reach detector first, 46. That's pretty simple. Calculate mass in kilograms of this. Well, the mass is just going to be 49 times by 10 to the power minus 3. And again, like I always say, if they've given you the Avogadro constant, 99%, I'm going to change that hopefully. I'm going to ask my teacher, is that factually true? If they give it you then 100%. But for now, I'm just going to say 99% over Avogadro's constant. And you get 8.1 times by 10 to the power minus 6. But be careful though. So I would just convert that 40 times by 10 to the power minus 3. 49 times by 10 to the power minus 3. It looks like 4.9, doesn't it? There you go. So 0.049. There you go. Just be careful, that's what I'm saying. This. Calculate time of flight of this. Alhamdulillah. Kinetic energy is this. 1.013 times by 10 to the power minus 13. Time is this. Okay, this one's a different one. Reason being is because it wants me to find the time of a different ion, and it's giving me the time of a different ion, and it's giving me the kinetic energy of any ion, of the ions that. Okay, so I've got the kinetic energy. Do I use any information? No, I don't think so. I want to calculate time of flight like this. But I've got, what I need to do is I need to find the distance. I think distance is going to be the connecting barrier between these two ions. Because, hear me out, if I'll rearrange this formula. Actually, no, I don't need to. Because I just write the normal formula, K equals a half mv squared. And I'll just work my way from there. So 2ke equals mv squared. V equals the square root of 2. I already memorized that, so I don't know why I rearranged it. I've got the kinetic energy, the mass. Imran, how do you get the mass? Well, the mass of this, I've already got from the previous part. 8.1 times by 10 to the power minus 6. 8.1 times by 10 to the power minus 6. I'm just going to write the units because they can be very tricky. They want it in grams, or they want it in something else. The 1 moles, they need time of Avogadro's constant, but then you want it also the MR, so you want it in grams. So be careful. So velocity, therefore, you can find out velocity, then you can find out the velocity of this, and then you find out the length of the flight tube, because you've got the time of this. Velocity equals distance over time. Therefore, distance equals velocity times by time. Very simple rearrangement. And then you can find out the velocity of this ion, because you can work out the mass of this ion, which is the same thing, 47 times by 10 to the power minus 3 over Avogadro's constant. And then the velocity is distance over time. Distance is a velocity. That's the mass, and then you can find the velocity by substituting to this formula. And then I think I overcomplicated it too much, but It should work. I'm gonna try this actually out on a piece of pen and paper. So what did I say I was gonna do? I was doing a quick little flash card. I said I'm going to find the velocity. I'm also going to take a screenshot of this because I'll ask my teacher if my method is perfectly acceptable, because surely as long as I get the correct answer it should be fine. So I find the velocity. So velocity equals square root of 2 ke to 1.013 divided by 10 to the power minus 13 over, I'm just checking if I'm going to do this and compare it to Mark's scheme. If I'm correct, then you guys can definitely use this method, I'm pretty sure. Over the mass, which is 8.1 times by 10 to the power minus 26 kg. Let's find that out. Square root of 2 times by 1.013 times by 10 to the power minus 13 divided by 8.1 times by 10 to the power minus 26. And I get a ridiculously large number, 1581529.187 meters per second to the power minus 1. But that's the velocity for this one. Then I can find the distance, because distance can be the same. Velocity is distance over time. Distance is velocity times by time. Distance. No, sorry, I can't do that because I don't. Wait, what? I've got the velocity, and then velocity is distance over time. Distance is velocity times by time. Answer times by no, because that's the velocity. I almost forgot. That's the velocity specifically for the 49 Ti plus. So I can't then substitute this to find distance of to find the time of this. But I'm not even trying to find this. No. Okay, so I've got the velocity 1581529.187. Then I do use that. I get actually 29.187 times by the time 9.816 times by 10 to the power minus 7. Never mind. Then I get the 9 point. No. Yeah, that is the time of flight. And yeah, so you get 1.55. That's the distance. Then in order to find the time of this 47 Ti plus, well, 1.55 velocity equals, sorry, time equals 1.55 over v of the 47 Ti plus, and v equals square root of 2 times by 1.013 times by 10 to the power minus 13 divided by, well, 47 Ti plus, so 0.047 divided by 6.022 times by 10 to the power 23, and then I get the velocity, and then the time is 1.55 over my answer. I get 9.62 times by 10 to the power minus 9.6 times by 10 to the power. Yeah, that's what the mark scheme pretty much got. So it should be fine, I guess. If you understand it that way, like I do, then yeah, try it out. In terms of atomic particles, state difference between three isotopes of magnesium. Isotopes, atoms same number of protons, different number of neutrons. So statement would be they have different number of neutrons. State how if the chemical properties of these change. No difference in chemical properties, as they all have the same electronic configuration. What does that say? 25 mg 25 mg atoms make up 10% in the sample of magnesium. Magnesium has AR this. It uses information to use percentage of other two magnesium isotopes present in the sample. When I first just read that to you guys, I was like, oh my days, not this again. An easy topic. Yeah, AR, relative atomic mass, but it's just a weird question, weird context. But in reality, then I read it again, and obviously from the practice from those previous questions, I know what to do now. AR 24.3 equals 25 is 10%, and I've also got 24 and 26 plus 24 plus 26 over 100 because it's a percentage, obviously. Now what happens? Well, I'm going to let one of them equal y. It doesn't really matter which one. So I'm going to let 24 mg equal y. So that's going to be 24y. And then for this 26 is going to be bracket. So it's going to be 26 plus 26 bracket 100 minus 10 because that's 10% of that. 10% of mass, 90. 90 minus y. 90 minus y. And that's the hardest part of this question. AR 24.3 because 24y plus but because it says percentages of this, yeah, you could therefore say 0.24. No, sorry, that 10% should be 0.010, and that should be, I guess this is fine though. You could just do it this way surely and then divide by 100. So yeah. But yeah, the hardest part of these questions is constructing this thing using algebra. But remember, do not overcomplicate it. Just let one thing equal y, and then therefore the other one is just going to be 100. Generally, it's 100 minus. Well, if this is, let's say this is y, then it's going to be 100 minus 2y, and you're 26 on the outside. But because it's not, that's 10. So it's going to be 100 minus 10, which is 90. 90 minus y. Calculate distance travel in meters of time of flight drift region. Time of flight mass spectrometer. Each ion is accelerated kinetic energy of this, and time of flight is this. Another question like this. They love to ask these questions. Kinetic energy equals 4.52 times by 10 to the power minus 16. Time is 1.44 times by 10 to the power minus 5. I want to calculate distance travel again to give me Avogadro's constant, so 99% chance I'm going to use it. I like to say 100, but 99% chance just for the sake of YouTube. So I need to find the mass. Well, okay, there we go. If I just read the question properly, it would have given me that 25 mg plus iron. Therefore, now it's easy. Now it's so easy. Just if I read the question properly, just before I said anything, there you go. That's the mass. Rearrange this equation. Oh, never mind. I already memorized it off beforehand, which I recommend you guys do as well. V equals square root 2ke over m. I've got kinetic energy. Substitute that into there. Substitute that into there. You get the velocity, but Iman, that's the velocity, not distance. Yes, but velocity is distance over time. Therefore, the distance is the velocity times by time. And you just worked out velocity. The only thing you don't have is time. Never mind, you do. It's given in the question. And that's it. You get 2.13. Just spotting that. If you're really struggling, label each part out and then just spot them, because you can't afford to lose 4 or 5 marks in these questions. You cannot afford to lose that, especially from the A A-star grade, inshallah, like I do. Element Q. Element Q forms sulfate with formula QSO4. Which of these corrupts an electronic configuration of an atom of Q? Q forms a sulfate with formula QSO4. What is this multiple choice question? Neon. Well, how many electrons does neon have? Neon has 10 electrons. Right. Well, just by looking at that, it's definitely not going to be that one. What did I even say again? 3s1, 3p2. No, it's 3s2, 3p1. The answer is, you know what? This is a difficult multiple choice question. I'm not going to go through it. There's no point of me just telling you guys the answer. That will be in a separate video. I'm struggling with that one. Question 24. Calculate relative atomic mass of Q and give the answer one decimal place. Identify the element Q. Okay, this one's a bit different. It tells me to identify the element. Relative atomic mass is going to be fairly simple. But is it? Is it going to be fairly simple? I don't think so, because I think most students would make this silly mistake. I honestly think a lot of students would make this silly mistake. Divided by 100, because you're so used to it. But you're not divided by 100, you just divided by total this, which is 26 plus 5 plus 3 plus 7, which is 41. So you're dividing by actually 41. There you go, you're dividing by 41, and then you get 84. And then to identify the element Q, well, what is that? Well, atomic mass of Q is 84. So we go to 84, well, what is atomic mass? Remember, this part is a top number. It's not the bottom number. So if you look at that, it's going to be krypton. I'm just jotting some key points down. Top number. Krypton 8436. Because you don't know which question is going to be in the exam. If you're prepared for all outcomes, you're ready. Calculate the time of flight of this. Okay, again, they love reusing these questions. I'm just going to scroll up, show you guys. This one, it gives you the time of one ion and wants you to find time of another ion. In this case, it gives you the time of one ion and wants you to find time of another ion. They probably saw not a lot of students did good on that question because it was a slightly difficult question. Okay, so what do we do? Does it give me the kinetic energy? It's got to give me something to work with. Well, it tells me the kinetic energy of each ion is a half mv squared. Which is, yeah, it's just put in a different format because usually it's like this. Ke equals a half mv squared, but in this case, the half is like a coefficient of mv squared, which it is. Because every mv squared you can times by half. And velocity is this. Time of flight is this. Calculate time of flight is this. So what I would do is, okay, velocity is distance over time. Time equals distance over velocity. But I don't know the distance of the flight tube. That's going to be a big problem. So I can't do that previous method that I did before. I just can't do that. So let me clear this up. I'm actually going to take a screenshot of this. Because these are the questions I need to be doing. Because these are, and you guys as well, obviously. This is a pretty difficult question. If this came up, I don't know if I would have got this. I don't think I would. What I'm going to do is, because the time of flights, well, the distance is the same. So in this case, 82 over this, because velocity is distance over time. Time is the distance though is a constant, and it's the same for each one. Time is 82 over this squared equals 86 over t squared. And if we rearrange, you get t equals 1.273 times by 10 to the power minus 5. Now I'm gonna check what this is because it's a really weird question. If there's a particular method to memorize to attack these kind of questions, I'll let you guys know and post a full video on it. Bromine exists as two isotopes which are found at almost equal abundance, which name is correct. Again, this multiple choice question is very difficult as well. Use periodic table to reduce the full electron configuration of calcium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. With excess of water, Ca solid plus 2H4 liquid to form what? Ca2 plus aqueous plus 2OH minus aqueous plus H2 gases. The role of water, oxidizing agent. And when I finish this part of the question, I'll just go through some real quick. First, ionization energy. So remember, it's the opposites. First, well, that's going to be positive charge here. So you have plus gaseous there, plus E minus. Okay, so just from this part, you should be able to get this from your skills of electron configuration. Calcium is not that difficult. This ionic equation, okay, I agree, it's slightly difficult. The role of water in the reaction with calcium, oxidizing agent, that's again just AO1, I guess. Knowledge, because this is in group 2 and group 7 elements. Equation first, ionization, again, your skill. So you should have at least got 1, 2, 3. This one's pretty hard. It's not necessarily equation you have to memorize, it's more application, right? It is a skill, but it's still a difficult question. So that, and then explain trend first, ionization energies of elements group 2 from magnesium to barium. Okay, so not many questions left. Magnesium to barium. Magnesium to barium. Magnesium to barium, or barium, it's actually not that way, it's downwards. And we know generally the first ionization energy decreases down a group. And I'm going to write that down because it said explain the trend. Well, the general trend is it decreases. Why? Ions get bigger, more energy shells, weaker attraction of ion to lost electron. Use information to determine whether the Bunsen has the mass number of the third isotope. Again, another weird one. But this one is pretty easy because I want to determine the mass number of the third isotope. So this one going to be the third one. The mass number, what is this? Y? Well, the percentage abundance is just 100. Total percentage, well, percentage add up to 100 minus 91 plus 1/8. Then you find that, and then you just, that's 32.16 relative atomic mass. 16 equals 32 divided by 91 plus 33 times by 1.8 plus whatever that is, 100 minus 91, 100 minus 91 minus 9.8, or you could say 100 minus 91 plus 1.8, 7.2, so 7.2 y over 100 because it's percentage. Rearrange, you get y, and y is mass number, so y equals 34. So what I mean is pretty easy. It's easy if you compare it to the ones before, whereas yes, you are using algebra, but it's very basic. But the other ones, it's like you've got a y, you've got a 2y, and then you need to identify, okay, there's going to be 100 minus 3y, and then your mass number, like 82, 24, for example. You need to be able to spot that. Describe how ions are formed in a time-of-flight mass spectrometer. Well, it doesn't necessarily state which one. That's really unusual. So I can either talk about electro spray or electron impact. And that's a really nice part about this question. Or is it? Or would most students just give both? I don't know. I probably would give both then, yeah. But now I'm exposed to this kind of question. I know it means either give electron spray ionization or electron impact ionization. And in that case, I'll give electron impact because I'm more confident with that. So sample is vaporized and an electron gun is used to fire high energy electrons, knocking one electron off each particle, hence becoming +1 ions. So electron impact, do I have to, okay, I'll just let the examiner know it's electron impact. So samples bombarded from vaporized electron going used for high energy electrons. There you go. And knocking one electron becoming 1 plus ions. It was necessary to analyze molecule measuring the mass on a flat mass spectrometer. Ions will interact with and be accelerated by an electric field. However, molecules will not interact with and be accelerated by an electric field. And the idea, only ions create a current when hitting the detector. Ions will interact with and be accelerated by electric field, however molecules will not will not interact with and be accelerated by electric field. Only ions create current when hitting the detector. Identify species responsible for 2 peaks. Sample arsenic acid, ethandoic acid, 2 peaks. Identify species responsible for 2 peaks. Ethandoic acid. Mixed with excess unknown alcohol, put strong acid catalyst, products separated, analyzed. So MZ104 yeah, again another tricky question. So I would go back to that. Long hand time of flat mass spectrometers separate 2 species to give 2 peaks. I know it's going to be the idea of the MZ values, or MZ ratio, what we want to MZ values here, and speed. So hitting the detector first. Detector first. So I'd probably say, well, I would probably say the acceleration of the positively charged ions are accelerated by electric field. Positively charged ions are accelerated by an electric field to a constant kinetic energy positive ions of MZ104 have the same kinetic energy as those of MZ108. However, they also move faster as a lower MZ value, hence MZ of 104 reach, hence ions of MZ104 reach the detector first. So same general principle though, this is an unusual context. Positive charged ions accelerate by electric field, obviously, so they will have the same kinetic energy, or you can say constant kinetic energy. Positive ions of this have the same kinetic energy as this. This one's just a comparison statement. I don't know why that's in there. And then the rest of it is the same. The move faster has lower MZ value, hence ions of MZ4. Move faster, lower MZ value, reach detector first. I'm just ticking these because those are not for marks, but just the key points I would include. And that is it for atomic structure question paper. Obviously, a couple of questions I have not included, but I will be going through them. I will be going through them in separate videos. Hopefully, you guys found this useful. And yeah, I definitely will be finishing the question papers for all of the A-level chemistry topics.